Good afternoon, students. Can you hear me?
Yes, ma'am. Good afternoon, ma'am.
Yes, good afternoon. So, shall we start now?
Yes,
Yesterday I
ma'am.
have given exercise problems. So everybody solved it.
Yes.
So there is no problem. I hope everybody solved it. So yesterday we have seen how to solve homogeneous difference equation with constant coefficients. Now in today's lecture we will see how to solve non-homogeneous difference equations. Okay. So lecture 21, solving non-homogeneous difference equation, linear difference equation with constant coefficients. So consider non-homogeneous linear difference equation with constant coefficients as follows. That is also nth order. Consider non-homogeneous linear difference equation. Nth order we can say. Nth order. Consider nth order non-homogeneous linear difference equation with constant coefficient as follows. Y at t plus n plus pn minus 1 y at t plus n minus 1 plus and so on p0 y at t is equal to r at t. So where pn minus 1, pn minus 2, p0 are constants with p0 is non-zero and r of t is any given function. R of t is any given function of t. Function of t. So our aim is to find what is yt which satisfies this equation. Okay. Earlier we have seen the equations when rt is equal to 0. Now we have to see when rt is non-zero how to solve it. Okay. So first method is annihilator method. Annihilator method. So what is the idea of this annihilator method is so we have to annihilate this r of t. Annihilate means if we operate some operator on rt, we will get it as 0. So our aim is to, in annihilator method, we have to annihilate r of t so that we will get homogeneous linear difference equation with constant coefficients, and we know how to solve homogeneous constant coefficient, homogeneous difference equation with constant coefficient. So we will apply the same method whatever we have did it previously. Okay, so we will see, we will give the equation number. It is given as 3.9. So consider equation 3.9, and it can be written as equation 3.9. It can be written or we can say it can be written equivalently in the form in terms of shift operator, right? It can be written in terms of shift operator as how I can write in terms of shift operator, e raised to n
e raised to n plus
minus 1
p
e raised
minus 1
to
e raised to n minus 1
so on plus
p0
operated on yt is equal to r of
r
t,
of
right? Now this is nth degree polynomial in E, and now if I find some function which annihilates r of t, that I will operate on both sides, so that that function into this operator operated on yt is equal to, I will get 0, and which will be converted as homogeneous equation, and then we will solve that homogeneous equation and we will find that yt. Okay, so we will write that in the form of theorem. Suppose that yt solves equation 3.9. What is 3.9? My yt plus n plus pn minus 1 yt plus n minus 1 plus and so on, p0 yt is equal to r of t, that is e raised to n plus pn minus 1 e raised to n minus 1 plus and so on, p0 operated on yt is equal to rt, and rt satisfies some another polynomial in E, say e raised to m plus qm minus 1 e raised to m minus 1 plus and so on, q0 operated on r of t is equal to 0. Then yt must satisfies e raised to m plus qm minus 1 e raised to m minus 1 plus and so on, q0, then e raised to n pn minus 1 e raised to n minus 1 plus and so on, p0 operated on yt is equal to 0. Is that okay? What is given? Suppose that yt solves equation 3.9, this non-homogeneous with constant coefficients.
मॅम
येस,
आवाज येत नव्हता इतके वेळ.
आवाज येत नाही आता.
आता येते मॅम.
Okay. So now can you see and hear na?
येस मॅम.
Okay. So whenever you feel problem, at the same time you can disturb and you can point out that problem. Okay.
ओके मॅम.
So now I can go ahead.
येस मॅम.
So we have to show this. Okay. So how we can show this? Just we have to operate. This is say equation 1 and this is equation 2. This is equation 3. Since from